It began with silence, then a whisper from the edge of the solar system. The world had almost forgotten about 3IATLAS, the interstellar visitor once dismissed as a mere curiosity. But now, in the fading light of 2025, it had returned to the center of global attention, not because of rumor or speculation, but because of numbers. Cold, precise numbers that refuse to obey the laws written into every textbook of celestial mechanics. The first alerts came quietly from observatories in Chile, Hawaii, and Australia. Post-perihelion images revealed something no one expected: a compact nucleus, sharp and bright, without the majestic tail that had defined its earlier approach to the sun. Instead of a plume of dust and gas stretching millions of kilometers into space, there was only a faint, symmetrical halo. To the untrained eye, it might have seemed ordinary, but to the astronomers who spent sleepless nights tracking its every pixel, the implications were profound. Dr. Elaine Porter, a researcher at the Cerro Tololo Observatory, was among the first to notice the anomaly. "We're seeing lateral displacement," she told her team, "not gravitational drift, something else, something pushing it sideways." Her words echoed across encrypted channels, sparking curiosity and unease. Non-gravitational acceleration had been observed before, in comets shedding gas and ice, but never with such precision, never with such restraint. Soon the data poured in. Independent teams confirmed it. 3I/ATLAS was accelerating laterally, as though guided by an unseen hand. No vertical displacement, no random wobble. Its trajectory seemed controlled. By early November, the story had leaked. Headlines erupted: "Atlas defies physics." "Harvard astrophysicist calls data impossible." And yet, amid the storm of online speculation, official channels remained silent. NASA's feeds slowed to a crawl. The European Space Agency issued a single vague statement about ongoing analysis. The world watched and waited for clarity that never came. Then, on November 4th, the silence broke from an unexpected source. At 8:37 a.m. Eastern Time, former U.S. President Donald Trump posted on his Truth Social account, "Effective immediately, Sean Duffy has been replaced as NASA Administrator. Welcome Jared Isaacman, an incredible visionary who will lead us to the stars." The post detonated across every news network within minutes. Was this a routine reshuffle or something far more strategic? Timing was everything. The announcement came less than 24 hours after Duffy's now-deleted exchange with Kim Kardashian on Twitter, an odd, almost comical event that suddenly felt like camouflage for something serious. Within hours, hashtags like #AtlasGate and #NASAControl trended worldwide. In laboratories and conference halls, scientists tried to stay focused on data, but behind closed doors, conversations darkened. Why had NASA gone silent just as Atlas became most mysterious? Why replace the agency's administrator in the middle of a government shutdown when no new policies could even be enacted? Across the Pacific, another kind of silence was breaking. The Chinese National Space Administration had been monitoring Atlas II through the Tianwen-1 Mars orbiter. And while the West debated politics, China prepared to act. On October 3rd, Tianwen-1's HiRIC camera had captured a sequence of images unlike anything seen before. Atlas, shining in the black void, a compact nucleus surrounded by a shimmering coma several thousand kilometers wide. The images were sharp, vivid, scientific proof, not rumor. From a distance of 28.96 million kilometers, the orbiter's 38.7 centimeter primary mirror recorded a moving target with remarkable clarity. The data were processed, verified, and compiled into a short animation showing Atlas drifting across the Martian sky, glowing faint green in reflected sunlight. When those images were finally released a month later, they hit the world like an electrical shock. Chinese researchers presented not only still frames, but a 30-second real-time animation, the first true interplanetary video of an interstellar object. It was elegant, mesmerizing, and deeply unsettling because the motion was wrong. Atlas didn't move like a comet pushed by solar radiation. It glided. Its lateral deviation was smooth, deliberate, like something adjusting its own path. That was when the whispers began. Inside congressional corridors in Washington, one representative decided to break the official silence. Anna Paulina Luna posted to her social media, "Just spoke with NASA regarding Atlas. They've confirmed anomalous acceleration similar to Dr. Avi Loeb's analysis. Data will be released once the government reopens. Bureaucratic delay, not suppression." Her message spread like wildfire. For the first time, a sitting congresswoman publicly confirmed that NASA had observed the same unexplained phenomena reported by independent researchers. 3 revelations emerged from her brief post. First, NASA's silence was strategic. They had data, but withheld it. Second, Dr. Avi Loeb's early warnings about Atlas's non-thermal acceleration were correct. Third, and most chilling, there might be other interstellar objects behaving the same way, quietly cataloged, never disclosed. The scientific community split in two. One camp demanded transparency. The other urged restraint, warning that releasing incomplete data could ignite global hysteria. Meanwhile, the numbers continued to evolve. Using the latest astrometric data, updated orbital models revealed 2 disturbing trends. The first, persistent lateral displacement. Atlas was not where it should have been, not by chance, but by pattern. The object's deviations appeared orchestrated, almost rhythmic. No comparable vertical displacement existed, suggesting an active control mechanism confined to the plane of motion. The second, non-gravitational acceleration that refused to fade. Even when reduced to 1/3 its initial magnitude, it remained statistically significant. The forces at play were real, measurable, and unexplainable by conventional cometary physics. To reconcile these findings, researchers turned to the standard comet model, outgassing. A comet ejects material, creating thrust like a miniature rocket. But the math didn't add up. To produce the measured acceleration, Atlas would have needed to expel billions of tons of gas and dust, at least 13% of its total mass. That kind of loss should have generated a massive radiant tail visible even through amateur telescopes. Yet every new image showed the opposite, a compact, stable nucleus, a modest coma, and nothing resembling the explosive exhaust required by theory. The paradox was undeniable, a 5 billion ton enigma that moved as if propelled by invisible engines, yet displayed no signs of the physics that should make such motion possible. Late one night at the Harvard-Smithsonian Center for Astrophysics, Dr. Loeb examined the latest spectroscopic data. His eyebrows furrowed as he read the composition report: nickel dominance, near absence of iron, and extreme carbon monoxide to water ratio. He whispered the words aloud, incredulous: nickel tetracarbonyl industrial residue. It was absurd, an impossible signature for any natural object. Nickel tetracarbonyl is a compound associated with metallurgical processing, not cosmic ice. Yet the readings were consistent across multiple instruments. Optical polarization studies deepened the mystery. Instead of the moderate positive polarization typical of cometary dust, Atlas exhibited extreme negative values, pointing to large, porous, complex particles. Materials engineered, not random. Each new data point chipped away at the walls of normal science. Could Atlas truly be natural, or was it something built? By mid-November, whispers had become theories. Forums buzzed, podcasts exploded, and late-night talk shows speculated freely. Is Atlas an alien probe? Did NASA know earlier? But beyond the noise, within the laboratories, the truth was far more fragile. Scientists were no longer sure what they were observing. The equations no longer behaved. The parameters that once governed celestial dynamics, gravity, mass loss, radiation pressure, seemed insufficient to explain what Atlas was doing in the silent dark. And yet every telescope, every radar ping, every photon streaming toward Earth carried the same message. Atlas was still moving, moving in a way no one could explain, moving towards something that waited in the shadows of December. By late November, the world had entered a strange quiet. The American government shutdown continued, freezing research budgets and halting NASA's data releases. Across the world, telescopes kept their eyes on Atlas, but the public saw nothing new. Every frame, every update remained locked behind bureaucratic firewalls. Yet beneath that silence, the story was mutating. Leaked emails, whispers from inside research labs, and encrypted forums hinted at internal conflict within the agencies. Scientists were divided. Some wanted to publish everything immediately. Others insisted the data be held until proper verification. But verification of what? In one of those anonymous threads, an astrophysicist from the Goddard Space Flight Center wrote, "We've cross-checked the acceleration vectors. They don't behave like outgassing. They behave like control burns." The message vanished hours later, deleted, the account suspended. But the phrase lingered, control burns, a pattern of deliberate thrust, faint but measurable, as if Atlas was fine-tuning its own orbit. While the public waited for official clarity, another piece of the puzzle surfaced, this time from Europe. The European Southern Observatory released partial optical data showing rapid polarization shifts synchronized with Atlas's rotational period. The values were extreme, unprecedented, incompatible with ice dust reflections. Something metallic was flashing across its surface, but too faint to resolve completely. At the same time, China's National Space Administration doubled down on its openness campaign. On November 22nd, they held a live broadcast, scientists presenting frame by frame the latest HIRIC analysis. The nucleus appeared solid, irregular, layered. The spectral lines confirmed nickel dominance, trace carbon monoxide, negligible silicate content. "We are looking," one researcher said carefully, "at a material of unusually high reflectivity and density." The stream went viral. Within hours, English subtitles circulated online, and the phrase "unusually high reflectivity" trended across every major platform. A growing chorus of independent analysts, astrophotographers, data modelers, even amateur scientists, began aligning the Chinese coordinates with archived NASA tracking logs. The alignment was perfect. Both agencies were watching the same enigma, and neither could explain what they saw. That evening, CNN ran a quiet headline, "Atlas may not be what we think." It was cautious, understated, yet something in the tone carried an edge of fear. Inside Harvard's CFA building, Avi Loeb gathered his team for a late meeting. The lights were dim, the screens filled with spectral graphs. "If these readings are accurate," he said softly, "then Atlas is made of something refined, processed, not primordial." His students exchanged uncertain glances. "You mean industrial?" one asked. Loeb didn't answer. He simply exhaled and turned back to the data. Outside, the first winter snow dusted Cambridge in silence. 2 days later, another signal appeared, not from the skies, but from Washington. In an unannounced press briefing, newly appointed NASA Administrator Jared Isaacman made his first public comment. Standing at the podium, he looked confident, rehearsed. "Our teams are working with international partners to ensure transparency and accuracy. Atlas represents a fascinating object of study. We will release comprehensive data as soon as the fiscal review concludes." It was the kind of statement designed to calm, but the timing, so close to the Chinese broadcast, only deepened suspicion. Reporters shouted questions. Was Atlas artificial? Was there coordination between nations? Isaacman smiled thinly. "We're scientists, not dramatists. Let's wait for the facts." Then he walked away, leaving behind a dozen unanswered questions and a trembling silence. Across the Atlantic in Geneva, a private consortium known as Orion Data Collective released a compressed archive compiled from multiple public observatories. Inside were raw photometric readings spanning the previous 6 weeks. When independent experts ran the numbers, they discovered the impossible. Atlas's non-gravitational acceleration was not random noise. It followed a recurring rhythm. Every 11.7 hours, a subtle modulation appeared, a pulse of motion, as if some internal mechanism adjusted its orientation. The revelation spread overnight. For the first time, data hinted at self-regulation, a property no natural comet had ever displayed. Within hours, the debate turned into a storm. Is Atlas alive? Is it a probe? Is it a natural body exhibiting new physics? Mainstream scientists urged caution, but the world's curiosity was already unchained. News channels replayed animations of the Tianwen-1 sequence, overlaying graphics of artificial thrusters, reactors, alien schematics. YouTube filled with speculative documentaries, each more dramatic than the last. Then, amid the frenzy, a small line appeared in the International Astronomical Union Bulletin. Astrometric residuals from multiple sources confirm lateral displacement exceeding 1.4 arcseconds per day, consistent with controlled trajectory correction. No comment followed. But the phrasing, controlled trajectory correction, was enough to ignite an inferno. Inside NASA, panic simmered. Senior analysts demanded retractions. Political advisors called for restraint. The official explanation shifted again. Localized jet ejection, highly directional outgassing. But no one was convinced. The data didn't show the expected coma jets or asymmetric brightness. Atlas remained clean, geometrically sharp, unnervingly steady. Meanwhile, radio observatories in Puerto Rico and Australia detected intermittent spikes near the 1420 MHz hydrogen line, the same frequency where the famous WOW signal had been detected in 1977. The spikes matched Atlas's position with eerie precision. The amplitude was weak, transient, repeating only when the object passed specific right ascensions. The scientific community tried to explain it away, interference, cosmic background noise, but the coincidence was impossible to ignore. For the first time, Atlas and the WOW region were being mentioned in the same breath. December loomed. Astronomers called it the decisive window. Between November 30th and December 19th, Atlas would cross a region of sky perfectly aligned for simultaneous observation from Earth, Mars, and the James Webb Space Telescope. Data coordination was already underway, but not everyone wanted that data released. Internal memos leaked from NASA hinted at security review procedures for all high-resolution images. Several engineers privately admitted that the agency's data servers had been accessed by external actors. No one said who. In the midst of the chaos, Loeb wrote an open letter to Scientific American. He urged calm and collaboration. Whether Atlas is a natural or artificial phenomenon, we stand before a chance to expand the limits of our understanding. Fear should not guide discovery. His letter was shared millions of times, quoted by journalists, mocked by skeptics, embraced by dreamers. For a brief moment, humanity seemed united in one shared emotion, anticipation. On December 3rd, new optical readings arrived from Japan's Subaru telescope. The nucleus shone brighter than expected, green and gold hues dancing across its surface. Its brightness curve rose sharply, not following the thermal curve of a typical comet. Something was illuminating from within, a steady pulse like the flicker of a reactor heart. Across multiple continents, computers buzzed, data streamed, analysts worked through sleepless nights. The final coordinated observation, December 19th, was marked on every calendar. Telescopes were prepared, satellites aligned, the world waiting for one night of truth. And yet, as that night approached, something subtle began to change. Atlas's acceleration vectors softened, its lateral movement decreased. The modulation rhythm grew erratic, as if whatever drove it was weakening or hiding. At 2:47 UTC on December 8th, the Tianwen-1 probe captured its final sequence before losing visual lock. The images showed Atlas shrinking in brightness, its green glow fading into a cold silver tone. Telemetry showed a new anomaly, a faint emission spike near microwave frequencies, non-thermal radiation unlike anything detected before. Then suddenly, the signal vanished. For 12 hours, no observatory on Earth could locate Atlas. The sky had swallowed it whole, and when it reappeared, 40,000 kilometers off its predicted path, It carried a new mystery waiting to be unveiled. When Atlas reappeared, it was as if the heavens had blinked. At 1412 UTC on December 9th, telescopes across 3 continents reacquired the target, offset by 40,000 kilometers, gliding smoothly once again. But this time, its brightness curve behaved differently. No gradual rise, no predictable fading. Instead, pulses, 3 sharp flashes, evenly spaced, each lasting less than 2 seconds. Astronomers thought it was sensor error. Then Chile confirmed. Then Japan. Then the Webb telescope itself. The pulses were real. Within hours, every observatory on Earth was watching. NASA's Deep Space Network pointed its massive dishes toward the coordinates. The results came back fragmented, scrambled, but one thing was certain. The pulses carried a frequency modulation, too structured to be random. At Harvard, Loeb stared at the waveform display, his hands trembling slightly. "That's not natural," he murmured. "That's patterned." His assistant leaned forward. "A message?" "No," he said after a long pause. "At least not one meant for us." Meanwhile, the political world was unraveling. The White House issued a carefully worded statement denying any link between the Atlas data and the sudden series of security briefings taking place across NASA, the Pentagon, and the Department of Energy. But satellite logs revealed unusual network activity between those agencies and the Space Force Command Center in Colorado Springs. Something was being coordinated, fast. By December 11th, the global press had caught up. CNN led with "Atlas emits signals." The BBC countered with "NASA declines to comment." Social media turned the story into chaos. Hashtags, #Atlas signal, and #December 19 countdown dominated every platform. Across forums and podcasts, the countdown had begun to December 19th, the night when Atlas would cross the coordinated observation line, the decisive window. At the Cerro Tololo Observatory, Dr. Porter adjusted her instruments under a thin veil of Andean mist. "We may only get one chance," she whispered to her colleague. "If it maneuvers again, we lose it forever." Back in Washington, Jared Isaacman stood before a wall of screens showing live telemetry feeds. His tone was steady, his eyes hard. "Whatever happens on the 19th, the data stays classified until reviewed. No leaks, no speculation." But outside that room, speculation had already consumed the world. December 15th. New spectral data showed Atlas radiating faint gamma signatures, non-thermal emissions inconsistent with natural decay. The readings were weak, but clear enough to rule out random background noise. The object was doing something active, energetic, unseen. Then, December 18th. Hours before the coordinated observation, multiple stations detected a surge in polarization, spiking to levels never recorded before. The light from Atlas fractured into shifting patterns, as if reflected by rotating panels of unknown geometry. Even skeptics could no longer explain it as cometary dust. At midnight UTC, December 19th, the decisive moment arrived. The James Webb Space Telescope, Tianwen-1, the Hubble, and over 50 ground observatories locked their instruments on the same patch of sky. A synchronized observation, the most extensive in human history. For 20 minutes, Atlas shone with steady brilliance. Then something extraordinary happened. A burst, not explosion, illumination. The coma brightened into a perfect ring, expanding outward like a ripple in space. The core remained intact, glowing white-blue. Within that momentary flare, instruments registered a brief, intense emission at 1420 megahertz, the same hydrogen line frequency as the wow signal. A signal so pure it cut through the static of the universe for just 1.8 seconds. Then silence. The ring dissipated. The nucleus dimmed. Atlas continued its path, untouched, unbroken, fading into the black. When the data arrived, no one could explain it. The frequency match, the geometric pulse pattern, the absence of debris, all contradicted natural models. Even the revised jet ejection theory collapsed under its own math. In the aftermath, NASA released a cautious statement. Preliminary analysis suggests complex, non-gravitational behavior consistent with high-velocity particulate emission. No evidence of artificial origin has been confirmed. It was a denial without conviction, a sentence meant to close rather than clarify, but other agencies refused to stay silent. The Chinese Academy of Sciences published its report within hours. ATLAS exhibits energy output inconsistent with known cometary activity. Further study required. The European Space Agency quietly noted coordinated light patterns in its log. And Avi Loeb wrote one final paper, simply titled 3 Possibilities. He summarized the enigma into 3 truths. ATLAS was a natural object of unknown physics. ATLAS was powered by a non-thermal internal mechanism. ATLAS was built. He offered no conclusion, only a promise. The data will decide. Days turned into weeks. By January, ATLAS had drifted beyond Mars's orbit, growing dimmer each night. The world's attention waned. News cycles moved on, but the scientists didn't. In small, secure meetings, they pored over every photon, every pixel, every microsecond of the signal. Then came the final surprise. Deep in the archived telemetry from December 19th, a small subroutine flagged by an AI anomaly detector revealed a pattern inside the frequency modulation. Not language, not binary, a harmonic series, ratios corresponding precisely to hydrogen spectral transitions, a signature of awareness encoded in the most fundamental constant of the cosmos. It wasn't communication, it was acknowledgement. ATLAS had seen us. And as the new year dawned, the comet, if it was ever a comet at all, faded into the silence of deep space, leaving behind equations that defied gravity and a question that refused to die. Was it just the universe playing tricks on human perception? Or had something somewhere chosen this small blue world as a mirror to say, you are not alone? The final image released weeks later showed ATLAS as a single point of light against the infinite dark. No tail, no glow, just a solitary spark moving through the void, indifferent yet unforgettable. And for the first time, humanity didn't look away.